Good afternoon, thank you. My presentation will be a little bit more focused on one specific issue. I will ask your patient, and since it's not deep into technology, a little bit about technology, it will be probably very trivial to some of you and very less trivial for others. So I apologize in the beginning. In the past year and a half, I was working with AccessNow, a company based in Toronto that its mission is to collect and provide information about accessibility worldwide. We started, founded by Maya Ziv, who probably most of you know her. We started as a crowdsource company, and later on, we understood that in order to provide the critical mass of information that we need in order to be efficient, we have to look for other meanings to mine data about accessibility. And technology is means where the natural selection. In parallel, when from time to time you plan and then something happens, we were approached, I think it was 2 years ago, by Trans-Canadian Trails. This is the largest trails worldwide, and they start to discuss about us the issue of outdoors accessibility. And it's happened to me that this is even not addressed, and it cannot address from some reason that I will discuss later on in details. And I apologize from start that I tried to do a linear presentation, start, middle, end, but it was a little bit difficult because I'm going to do with two different issues. One is the AI, inclusivity and NI, and the second is about the outdoor trials, and eventually it will connect. I'll start with the AI bias. AI bias, AI inclusivity, and non-inclusive AI has made the right noise and objection in different communities with all over the world. It could be race, gender, whatever you can think that there is some group with specific needs or specific emphasis, then AI is considered to be inclusive. If we just look at these sites, and I didn't bother to get all of them, it's a well-known issue. Then if we want to solve it and we want to use AI, because this is a very powerful tool, then we have to look in the details. And in the details, and it's already was observed that the main problem in applying AI is not in the tool itself, but it's in the data. And we will put a pin to that in it, and we'll come again to it later on. So we'll start with an example about AI, how we are going to use AI. In this case, we will just want to design a car. Usually pick a neutral example is good. So let's say we want to start and design the car using AI. We have to feed the data. And the data in this case, again, this is very schematic description. The data in this case will be, we'll look at all the existing car brands, or we can do ask customers, do customer polls or whatever. And let's say that we start with looking at all the existing car brands, and we map them according to performance and cost. We accept to have some quasi-linear connection between the higher the performance, the higher the cost, but it's not one-to-one, naturally. So if you just apply AI to this whole section of all collection of the data, what will come up with the average car? This is the average car, because you look at the middle, and this, if you apply AI, it will catch the middle. It's like if you calculate the height of male or female, then probably basketball players will be out of the diagram. If you want to be more accurate, and now I speak about from strictly financial / business point of view, let's say that you are, again, I will use names not too much, like the Mercedes and the BMW and all this kind of cars, then you don't want to design for the car, but for the mid-section. So we'll just look at a different group of the cars. You take this as your input data, and then you can build a different type of car. It will not be for the whole market, but it will be very accurate, very appropriate, very attractive to its niche. Of course, you can go to other subgroups, but you have to be careful, because whenever you go, this is what you can get. The important lesson from that is it's nothing new, actually. I mean, AI, it said that Alfred Nobel was clinically depressed in his last days, because when he invented the explosive, the dynamite, he intended to be to the good of the people, to build roads, etc. And once he found that it was used as a weapon, again, he was just clinically depressed. And it's not the dynamite, it's how you use it. It's not the AI, it's how you use it. And it's not that it's required something that was not known before that. The solution is very simple. It's there, as the famous book said, when everything else fails, read the instruction. If you want to design, and let's say you want to design, there was a famous case of the credit card, Apple credit card, which was totally not inclusive for women, because pattern of employment. You cannot use one model. You have to build several models and apply each of the model to the subgroup. Again, you handle everything, but you apply the first model, take out the data from there, look in the other group, in this case like the blue cars, apply to them. You have two models. If you have one model, it's not enough. You have to use two models, three models, four models, according to gender, according to complexion, according to height, or whatever. If you try to build one model, usually you will miss a lot. So this is another pin that we are stick here. We'll come back to it later. Changing the subject from technology to a little bit outdoor, the great outdoor. We invested quite a lot. We already covered about 500 to 600 kilometers of trials, and we are going to, hopefully by the end of this summer, to up to 1,000 kilometers of trial covered, and we learn a lot about outdoor accessibility. It's not just whether a certain trial is accessible or not, but what it is at all. And it's different from indoor accessibility. In the built environment, let's say you have a government office, what is accessible is clear. You want to be able to go to service on Ontario and get the service. In outdoor, it's not exactly like that, because there is also a critical issue of the preference. In one scenario, you want to go trekking, or you want to go on a very extreme trail, or next Saturday, you want to go in something much more solid, much more easy. So it's not just whether it's accessible or not, it's also a preference. And it changes from person to person. We have mappers. Few of them like to have extreme trials, and few of them just like the Martin Goodman here in Toronto, asphalt paved all the way. So, once you assess for accessibility a trail, you cannot just say this is just accessible, not accessible, because it's not enough information. You have to provide the extra information, so someone who plans to go there and just want to relax, then he can do this, or someone who wants to get a kick of adrenaline, that this is a trial for him. I mentioned earlier that started by Trans-Canadian Rails, by others, Parks Canada. There is a lot of activity done in the last 2 years. We mapped, I will show some of the conclusions that we got about that. And all of this information about accessibility and is up in our website and app, free for everybody. It's part of the mission of our company to provide it. So whenever you're looking for a trial, just go AccessNow, click trial, and then you have a selection of trials that were already assessed. This is just, by the way, how it looks like. This is Vascana. You can see a trial around the lake in Vascana. You see that here all the amenities, the benches, washrooms, access points, whatever. Green means that it's okay and accessible. Red means not accessible. Yellow means like a yellow. And on top of that, you have some text. You have some review, what we call it. It was written by one of our mappers, and it explains an extra information that just drawings and symbols cannot provide. What we learn, and I mentioned earlier that we started as a crowdsource. Crowdsource give you information, but once you do the mapping itself, it can give you much more information, because once we start to map, we have a constant discussion with our mappers, and it starts some thinking process and understanding of what is the data that we are collecting, what does it mean to have accessibility in the outdoors. And I will give some examples. See this on the left, even you don't need to write inaccessible because it's clearly inaccessible. On the right, you have the grade. By the way, old school way to measure the grade. And here again, two more examples. Very steep hill, or you have this bridge which is width 1 meter. Now, the eagle eye here will probably notice that what is the difference between the left and the right in the two successive pages. And this is what we learned, actually. And this is, I think, one of the most important lessons that we learned in these 2 years. You have two types of data. You have the objective data, which is clear. The width is 1 meter. The grade is 2.8%. Whatever. It's measurable. It's important, but it doesn't provide the whole picture, because it doesn't cover everything. On the other side, you have the subjective. You have the rating. Someone who has a lived experience with disability went there with his wheelchair or his cane, and he said, this is accessible, this is not accessible, and this is not cannot be encompassed just by numbers. And again, one of the things that we learned is that you have to be able to address these two types of knowledge, which are different. And this is where first we kick in technology, because we have these two types of data. One way to show it is just to provide these two separate bulks of information, but there are some strong capabilities that were developed in the past 15 years, like machine learning, that allows you to take the subjective data and the objective data and build a model that tells you once it combines the two typology of data. I will try to give some more example about it later on. This is how we built the technology behind what we are doing. I'm not going to elaborate about it because this is quite elaboration. If anybody wants to learn more about it, then I'll be happy to do. Accessibility is a multi-dimensional problem. I mean in the mathematical engineering point of view, something that you have to solve. So you have to provide multi-dimensional senses. You have to use vision, you have to use the sound, For people with hearing disability, you have to use the kinematics, and I will show specific examples about that. And you can learn a lot from text, again, behind it. What is the most important here, and this is the pins that I mentioned earlier, and this is how you can really make your AI inclusive, is how you plug in to this mechanical system the subjective data. And again, something that we learn is you have to use people who map the area, who have lived experience with disability. They can tell you whether it's accessible or not accessible. So all our machine learning, all our technology is based on feedback and subjective data that was collected in all this project. All of them was collected with again, people who live in disability. One example that catch my eye on the right is, I will never thought, I mean, I saw many times these tables with this curve, this arc which is cut there. I have no idea what can it be used to. So this is why you need two people who understand what they are looking at and getting the data. So all these hundreds of kilometers, 15,000 places that we collected in 3 major cities in Canada this summer, everything, all of that was done by people with lived experience disability. And this is the data that we are laying. So everything is the inclusivity is built within the process. Now a little bit about technology, how we can use it. When we looked at what is the parameters that are important to TCT, Parse Canada, similar, American Old Trail, there are mainly 99.9% is the distance. I mean, how much did you walk and on a trail? The grade, for sure, critical, important. Ground roughness, important. Side slope, again, if you don't think about it, then you don't know how much important it is. Trail width and cellular coverage. So this is all measurements you have to take when you're on a trail. And the question is how you can do it easily without using this yellow grade method that I showed earlier. The solution is simple and complex at the same time. Every one of you that has a smartphone actually has a very complete, full of sensors. Whenever you move the phone from portrait to landscape, the mechanism that makes sure that the picture will move with you is based on 7 to 8 sensors which are in the phone. You have for sure the GPS, you have barometers, you have accelerometer, gyroscope, magnetometer, a lot of meters there. You have camera, and in the new iPhone also you have a 3-dimensional camera, LiDAR. All of these sensors are enough when they are augmented by the proper signal processing to collect all the data that is required. So in order to collect the data, what you need is just, you see the red circle, this is Michael, one of our mappers. The red circle, this is iPhone. Smartphone, not iPhone. So we have a smartphone mounted there. He just walk, trail, enjoy the trail, and the smartphone is collecting the data. And out of the data that's collected there, instead of using ruler, the data is just backed up to the cloud, processed there, and all the information is there. So we just have to trail, and the data is collected. I will give some example. This is width. This is how you calculate the width of a trail. Looks very simple, by the way. You see the width. You see there. This camera, the phone's camera, is mounted on the wheelchair. The wheelchair is moving, and you have this. The mathematics behind it, the algorithm behind it is quite complex. Because if you remember, maybe for CSI movies, whenever in the police they take some photo of an evidence, they put a ruler in. And the reason you need a ruler is to translate from pixels that you see in a picture to meters from 2D to 3D, to matters in real life. In order to do this in a simple video, you use all the sensor, the GPS, the accelerometer, the gyroscope, everything that you have on the phone. You build quite a complex estimator. It's actually a certain degree of freedom filter that calculates the speed of the wheelchair. Very accurately, the speed of the wheelchair. Once you have the field of the speed of the wheelchair, you can convolve it with the video and then get an estimation of the width of the tile. It looks simple, but it's as it read down, it's literally rocket science. Another example is measuring the ground roughness. Okay? This is Russell, one other mappers of us that you will see him soon. He took me here and said, look at this gravel. If you just cross the gravel, and I try to visualize this, you can see on the left the smartphone sensor, and you can see as he passed the gravel, all the sensors went berserk. And once you have this, then the practical way to do it is, again, he has the sensor. This is Russell in Huron Street, about 1 kilometer from here. He's moving on there, and you can see this is now smooth, and he just walks, enjoy and then bump, because all the sensor just, again, you can detect it from the sensor. Russell has to do nothing. Everything is go directly on the air to the cloud, process there, and then you can provide an accurate, real-time description of the level of roughness and bump. We were lucky enough about 6 months ago to be granted by the government of Canada to use quantum computer and grant for research in quantum computing. So we take everything up, scaling up. We assume that once we'll have not one mapper, but many mappers around the world. Then this is really teras of information, and we need some boost in computing. So we develop what you see, these squares is the work of my colleague, Mayan Goldstein, who helped me, our chief scientist. She's in Israel, so it's a little bit hard to come here today. This is what you see. This structure is actually a program for quantum computing that is used to detect whether this terrain that you saw earlier is smooth and bump. And the amount of real-time online processing that can be done is unbelievable. So the way we see it, not now, 1 year, 2 years, 3 years, we'll be able to collect the information and provide kind of a ways-like estimation of how to move from one place to the other based on this type of information. To conclude, how we combine everything. First, and this is quite optimistic, I think, conclusion. First, we have technology, and technology allows us to collect the data that we need. And we need a lot of data. It's simple to move with a car on a road. It's much more complex to move, with example, with a wheelchair on a sidewalk. And if it's more complex, it means we need more data. Now, machine learning helps us to synergize, to integrate the data that we got from the subjective data, the opinions, the way that a place is perceived with the numbers. And AI, when it's properly used, make this valuable information. At all, and it's good to note, awareness, I mentioned TCT, I mentioned others, awareness to accessibility outdoors is growing, and action are taken. That's all for me for today. Thank you.